We've all been working on our Python code and heard somebody say, well, you know how you get that to go faster, and then tell us something. And sometimes we do it, sometimes we don't. But this week we're actually going to stop and test 5 of the most common things that I've heard people say speed up your Python code to see if they really do or if they're just wasting your time. Welcome to another MetPy Monday. Hello, I'm John Lehman, a software engineer for Unidata. This week I want to look at 5 things that I've heard pretty often that people say, to speed up your Python code, you should just do this. And sometimes they just do them without having ever tested it. They just say, well, I've been told this and that's what I'm going to do. And we know as scientists that that's not what we're supposed to do. So we're going to take a look at these 5 things and see which ones are worth remembering and doing, and which ones make absolutely no difference. The first is on building strings. Now, we all know there are lots of ways that you can build strings. I'm going to declare a couple of variables here, a max temperature, a min temperature, and we want to build the string that says today's high is 27 and the low is 15 deg C. So that's our goal. That's what we want to build. Well, the way that you can do it where everybody will tell you that is slow, though it's a way that I see it done a lot, is something like this. So we're going to use time it to see how long these things take. To say something like today's high is plus string of max t plus, and the low is plus string min t plus space deg c. Now the downside to this is, well, for one, you have to remember all those spaces around the strings, but it does work and it's relatively easy to read, though you do have to wrap anything that's not a string in string to convert it, and that's kind of annoying. We see that we get about 550 nanoseconds. So not very long unless you're doing a lot of string building. It may not matter, but this is one that, like I said, I've often heard pointed out as a culprit of if you're doing a lot of string manipulation that's slowing your code down. So let's see how much better we can get it. Probably the most common thing that I hear people say, well, you should really never use plus on strings. You should use the join method. And let's try it out and see. So forecast text is going to be equal to today's high is dot join, when we can provide a list of things that we want to join together here. String max t. Okay. And the low is, so I still have to remember my spaces here. String min t, deg c, close the list, close the call to join. So let's see how long this one takes. All right, that's a little faster. That's 50 nanoseconds, 60 nanoseconds roughly faster. And part of the reason is when we're using the addition operator, one, we're having to, so today's high is plus string max t, that makes a new string. Then we're taking that new string, adding, and the low is, that makes a new string. So we're doing a lot of copy operations. But I'm going to say plausible here. Sure, this is faster, or I guess we could even say confirmed. Mathematically, it is faster. But is it the fastest? So let's look at another way we could do it. There's the older way, more like what we would do in C when we were doing string insertion and replacement bits here. So we're going to have one string. And then we will tell it the variables, max t, and min-t that are going to replace those placeholders. This works as well. It's not necessarily very readable, and you have to remember all those formatters. But if you're used to writing in C or some other languages, you probably know the formatters by heart anyway. 325 nanoseconds. So now we're seeing some very serious improvements, a couple hundred nanoseconds over our initial just using the addition operator. But it's not very readable. So let's try one more. This is probably the way that I do it most in my code because it's the most readable, which is using the F string. It's been around for quite a while now. So today's high is, then in curly braces, max T, and the low is min T deg Z. This is, to me, very, very readable, and it's 278 nanoseconds. So it's roughly half the time of our initial stab at this using the addition operator. So should you not use the addition operator for making large strings? Probably not. It is slower. If you're doing enough string manipulation, it could add up, but most of us are only doing minor amounts of string manipulation, so it's probably not the main bottleneck in your code. But there are better ways to do it, and join isn't necessarily the best. Again, test it out and see what you find for whatever problem you're trying to tackle. All right, so this next one I've heard several times. I think mostly from programmers that are coming from other languages, which use while one instead of while true. So what do we mean here? Well, 1 is a truthy value. Anything that's not 0 is a truthy value. So if I were to write a loop, a while loop, where I have some index I set to 0, and I say while true, I plus equals 1. If I is greater than 10,000, I want to break out of my loop. Not a very interesting loop, but we certainly do use while loops sometimes in our code. All right, so we get 548 microseconds there. Let's try it now. In fact, we're going to copy, just so you can be sure that I'm not doing anything sneaky. But we replace true with 1, which also evaluates to a truthy value. And the hypothesis here is that while 1 is going to run faster than while true. We get 544 microseconds, so a 4 microsecond difference with while 1 being faster. We can run this test a couple of times. And you could also unroll this. All of this you could really, if you wanted to test it out thoroughly, look at the disassembled version to see how many commands there are. We're not going to go into disassembling code here. So I ran this test again, and you see that this time while 1 was actually a little bit slower than while true. And we can run it one more time. I've run this quite a number of times. It seems like generally while 1 is slightly slower, or they're identical even sometimes. There are other things going on your system. So here while 1 was 2 microseconds slower. So use while true or while 1. Is while 1 really faster? No, this one's busted. All right, so that while we're talking about loops, this next one is in the same vein, which is use while loops, not for loops. Again, I've heard this generally from other language programmers. Haven't heard this one as much as some of the others, but I've definitely heard it around. So the idea here is if I were to say something like my sum is 0 for I in range 100,000, sum plus equals, or my sum, best not to use built-ins there, my sum plus equals 1 are reserved words, and then time it, my sum equals 0. I have to have some kind of index to get out of my while loop. While I is less than 100,000, sum plus equals 1, I plus equals 1. And we run that. It's my sum again. And we see this is actually significantly slower. So I find it interesting that this one has come up a couple times to me. If you should really use while loops because they're faster. Of course, it's situation dependent on what you're doing, and sometimes you need to use while loops because you don't know how many times you need to run through the loop. You don't know how long until you converge on a solution in a numerical method, for example. But in general, in Python, for loops are faster, and if you disassemble these, you see it's something like 3 versus 10 commands. It's quite a big difference because we're having to increment and keep track of this incrementer, whereas a for loop is just iterating over this generator. Also, while loops can't work over generators because they have to have a comparison. So interesting enough, this one's busted as well. For loops, generally, if you can use them for your application, are going to be a little faster. All right, our fourth one, I'm not sure where or how this got started, is use multiple assignment. So what does this mean? This means instead of saying something like my first variable is 1, my second variable is 2, my third variable is 3, and my fourth variable is 4. Instead of doing that, I should say first, second, third, fourth equals 1, 2, 3, 4. Wow, look at that. It was actually a fraction of a nanosecond slower to use multiple assignment. Now, if we run this test a few times, we'll get various 27.1, 27.5. So it's, in the last couple tests, been a fraction of a nanosecond slower. For one, that's not really much time penalty at all. But it is using this cool unpacking that Python can do. But is it really faster? No, if anything, it's a little bit slower, so this one's busted. Should you not use it, or should you use it all of the time? No, this is what we would say is a syntactic nicety that Python provides. This reads pretty nicely if I'm assigning a logical sequence of things. It reads a little more cleanly than this. It takes up fewer lines of code. But if what you're assigning, if you have 20 variables and none of them are really related, then you probably shouldn't do this. So do whatever makes your code more readable because you're not going to get your speed advantage here. And finally, the one that's likely to cause the most contention is don't get to a function using a dot. So let's test that, and what do I mean? I mean if I say import math, and I call math.square root, there's the dot of 256, versus saying from math, import square root, and then we're going to call, instead of math.square root, just square root 256. This is a very fast function call, so we're doing 10 million runs here, quite a few. And there is a slight time difference here. It is a little faster because it doesn't have to do the lookup in the math module for square root, so you get to skip that one step. And we know that function calls in Python are a relatively expensive operation. So let's run these again, see if that difference persists. About 20 nanoseconds last time. So we've got 127 on the first, which is pretty similar to our first run, and 101. So yeah, roughly a 20 nanosecond or so improvement here. Can you get a little bit more speed? Technically, yeah, it's plausible. It's technically correct. Should you do it? I'm on the fence here. If you're going to use a lot of things from math and you need that namespace separation, like maybe you've got a square root function from something else, say NumPy, or you've got your own square root function, probably not the best example, then no, that namespacing is very helpful for you. If you just need one or two functions from math and the namespace separation isn't important, sure, you can import them specifically. That is going to bring less things into your global namespace, and it should load a little bit quicker. So, can you get a speed up here? Yes. Is this probably the thing to start with to speed up your code? No. There's a lot more that you can do in your code. We've talked about profiling on previous MetPy Mondays. Generally, there's some very low-hanging fruit that you can get to before you have to get down to thinking about how you're importing something. But I hope that you found these 5 things that we showed you useful and maybe dispelled some of the myths that you've been told about Python programming. It's always a good reminder that when somebody tells you something in programming, it's great, but you should go test that out yourself. Make sure it works for you, make sure it works for your situation, and just make sure it wasn't a myth to start with. I hope that you found this useful, and I'll see you on next week's MetPy Monday.